All right, so if you graph this on Desmos or on your graphing calculator and use the standard window from -10 to 10 for X and Y, you'll see the graph that's on the screen. You can use the trace and or zoom and or just select on Desmos like you see that I have done to find some interesting points. So I have found and located my x-intercepts, and I could approximate what each of those x-intercepts are. I could approximate my y-intercept, and I see there's kind of an interesting turn happening here. So that one is also kind of highlighted. When I ask you to think about the domain, maybe you think, hey, it's all real numbers. But what I want you to do is I want you to go back to whatever you graphed this on, whether it was Desmos or your graphing calculator, and I want you to zoom way out and then zoom in on the graph when the y value is, like 2,000, okay? And I'll come back and I'll show you what that looks like for me. So I have zoomed way out, and what you'll see is that my y values, if you look over here on the right of the screen, are like 2,200 and 17, 16, and so on. And my x values you can see along the bottom here. So this is -2 here, -2.1, -1.9. So I've gone really far out, okay? And what I notice is that even when I'm that far out, I don't have an x value that equals -2. So really, what's happening here is what we call an asymptote. And if we go back to that original graph, we can kind of see that asymptote is right here. Okay, and what this says is that our graph can never go through the value of x equals -2, no matter what. I will never be able to reach x equals -2. If I try to plug in -2 into my function, I get a 0 in the bottom of my fraction. And we know that's a problem in mathematics. So that's why it's a value that doesn't work. So in this case, my domain, and we'll write this kind of in words first, is all numbers except -2. And then maybe in Algebra 1, maybe you wrote that as -infinity is less than -2. Nope, sorry. Is less than x is less than -2. And then you'd have to write, and then -2 is less than x is less than infinity. And that's a lot of stuff that we would have to write. But what we're going to do, so remember, this is what we called our inequality notation. And this is back in Algebra 1, you did that. So what we're going to do in Algebra 2 is what we call the interval notation. So the interval notation really just kind of looks at this as two parts, two graphs. So this graph on the left, I notice has a domain from -infinity up to but not including -2. So what I would do is I would say its smallest x value is -infinity. And then in that little section of the graph, the biggest we can get is close to -2 but not including -2. And then I look at the right side of the asymptote, and I see that we can't get to -2, but we can get super close to -2. And then the rest of my x values go out to positive infinity. So I would say from -2 to positive infinity. Now, when we have more than one part to our domain, we're going to use a little u in between, and that just is a symbol for and in mathematics. And then take a look at your range. So let's talk about range in words. Right? And the range in words, if you look, are there any y values that would not be possible? And it doesn't look like there are, because it looks like our graph continues to move down here and up here, and there's no place in here that I see I can't have a y value. So my range is all real numbers. Back in Algebra 2, using our inequality notation, you may have written that as -infinity is less than y is less than positive infinity. But for us, we're going to write that as -infinity to positive infinity for our interval notation.